Our world and beyond. Space, in partnership with the European Space Agency.
It's a great view of Atlantis.
Early morning, the 3rd of February 2008. The space shuttle Atlantis is ready for launch. 2 European Space Agency astronauts are part of the crew.
See.
Leopold Eerts is one of ESA's most experienced astronauts, an expert in long manned flights. With him, his German colleague Hans Schlegel. The cargo is a very special 75 cubic meter cylinder.
The first task was to actually get Columbus into space, and that's what we did. Hans Schlegel and me of ESA and 5 American astronauts. We were on board the shuttle Atlantis, carrying the European Columbus module and 2 other external experiments, all in the shuttle's cargo bay.
The payload represented the pinnacle of European technological collaboration.
Atlantis, as Columbus sets sail on a voyage of science to the space station.
Not too bad.
After the launch, it was onwards to docking with the ISS.
Okay, text my 85-foot safety tether is stowed near us.
The module was lifted out of the cargo bay and attached to the ISS using the station's robotic arm.
That's affirmative, Houston. Columbus.
5 days after liftoff, Columbus became a permanent fixture on the ISS.
Beautiful work, Leo.
After Columbus was installed, the next thing to do was to start the module up, meaning fire up the onboard system and start the mini science labs on board Columbus.
Et démarrer les mini-laboratoires scientifiques qui sont à l'intérieur de Columbus.
About 30 centimeters, please.
That involved setting up the racks of experiments, a maneuver that had been meticulously practiced on Earth.
Our toolkit, and we don't have the same kind of toric socket.
There were also 2 experiments that had to be installed on the outside of the module. They were called UTEF and Solar and were to be placed on these external platforms on Columbus. Then we had to get them going.
Columbus is a base for a host of experiments to be carried out in near zero gravity. They're contained in 5 racks like fitted cupboards. The tests have many goals, including to assess the effect of microgravity on fluids and animal and plant cells, and the physiological and psychological impact of weightlessness on humans on long space flights. On the exterior, the experiments are on the open space environment and solar radiation.
Aujourd'hui, on peut dire que le module est en bonne forme. Il a été
Today we can say the module is in great shape.
exploité, je dirais, de manière complète.
It's being used to the full by both ESA and NASA, which is also carrying out experiments.
Ce module est en fait partiellement utilisé par la NASA.
Columbus is also a symbol of international space cooperation and is Europe's biggest contribution to the ISS project. This is the German space agency, the DLR, near Munich. It's home to Columbus's mission control, known as COL-CC. For a year, monitors have been keeping a close round-the-clock eye on the lab, receiving a constant stream of data flowing from the onboard experiments. That's then relayed to the perhaps thousands of scientists around the world involved in the experiments. One example of how the information is being used can be found at the French space agency CNES. Here, the CADMOS Centre helps users prepare and develop experiments involving microgravity. Work's underway on a so-called 3D space experiment.
This experiment will allow us to evaluate the mental responses to spatial perceptions the astronaut's going to have. In other words, how the astronaut is going to process what he sees or perceives.
The equipment here is identical to that used on board Columbus. NASA's Greg Chimenoff did the same experiment a month ago. It requires 3D glasses linked to a computer, a high-tech isolating hood, and a special pen and mouse. A word or phrase is written several times on a pad which reproduces the shapes. The astronaut can't see what he's doing.
Les clics gauche, clic droit pour incrémenter et décrémenter.
Another aspect of the experiment is gauging distances using images projected onto the 3D glasses of the astronaut.
To make the most of the data, we collect information before, during and after the flight.
How the brain deals with the senses is hard to assess, even on Earth.
It's important to know the difference between perception and reality in relation to the distance and depth the astronaut perceives. For example, if an astronaut has a sensation of reduced space, he could feel cramped or restricted. He could feel more stressed or oppressed on long missions.
Writing feels natural, but there are other exercises that are less so. When we have to gauge certain distances, that can be difficult. I worry about the results and I think about the astronauts free floating in space. That's even worse.
Experiments on the ISS are done in the same way as on Earth, but working in microgravity requires modifications to the materials involved and a better understanding of the organisms being used.
Today,
we understand the limits of spaceflight. They're particularly psychological, medical and physiological. The ISS is certainly going to be used to improve these physiological and psychological aspects for future space exploration, in particular a return to the Moon and maybe later other planets like Mars.
Columbus will remain at the ISS for at least another 10 years, making its contribution to science and playing an important role in future space exploration.